Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss some of the important operating system fundamentals. To begin with, let us draw an understanding of the term operating system. Before understanding the significance of the term operating system, it's very important for all of us to understand the significance of the two constituent terms which are operating and system. Operating basically refers to the task of creating, preparing, initiating, allocating resources and its effective management, scheduling, controlling, coordinating, executing, handling exceptions, and eventually terminating purpose-specific business processes. Again, I'll repeat it. Operating refers to the task of creating, preparing, initiating, allocating resources and its effective management, scheduling, controlling, coordinating, executing, handling exceptions, and eventually terminating purpose-specific business process. So in order to execute any or every business process, we require operations. Now, operating as identified has a set of or host of sub-activities. Now, in order to effectively and efficiently perform these set of identified sub-activities, you need aid of a sound and a concrete system. So a system will be required or is required in order to achieve all the sub-activities that are associated with operating. Now let us formally and informally define system. A system informally can be defined as a collection of related components that are capable of collaboratively realizing a set of well-defined objectives. Again, I'll repeat it. A system can be informally defined as a collection of components, rather collection of related components that are capable of collaboratively realizing a set of well-defined objectives. Now, formally defining a system can be defined as a set of interacting or interrelated elements or components that act accordingly to a set of well-defined rules to form a unified whole. So, a system is a collection of components that are related to each other, that are collaboratively capable of realizing a set of well-defined objectives. Now, it is also to be understood that the very organization of a system or organization of any system is greatly influenced by the environment with which it is surrounded with. Again, I repeat it. The very organization of system or any system is greatly influenced by its environment by which it is surrounded. Because systems are built in order to solve problems that exist in the environment, or systems are built in order to frame solutions to the problem that exist in the environment. And to add to it, system is realized in order to interact with the elements that exist in the environment. So the very organization of the system or all the system is greatly influenced by the environment with which it is surrounded, because the system is supposed to work in the environment and supposed to provide solutions to the problem in the environment by interacting with the elements of the environment. Further, a system, whenever it's described, has to be described from these four important perspectives. First one being the purpose. It is very important for all of us to specify the purpose of the system, because purpose will list the set of objectives that the system is expected to attain or expected to fulfill. So it's important for us, for all of us, to specify the purpose of the system first, because purpose will list the set of objectives that the system is expected to attain. Now, it is also to be understood that whenever the purpose of the system is being specified, it's very important or very crucial for us to prioritize the set of objectives based on the relevance of the objective to the very existence of the system. It implies that it's very important for all of us to prioritize the set of objectives that the system is expected to attain. Depending on the specified objectives or the purpose of the system, the other elements of the systems are thought of. For example, what kind of structure the system would require, what kind of functions the system would require, what kind of complexities the system would require, what kind of data structure the system would require, what kind of scope the system would require. So depending on the purpose that is being built, we frame all the other subsequent relevant concepts and content. So the first one is the purpose. Now once the purpose specified, then the second concept that we focus on is the system boundary. Now it's important for all of us to fix a well-defined system boundary with a system. The system boundary basically dictates or determines the extent to which the system goes in order to provide solution to the problem that is there in the environment. In simple terms, boundary basically refers to the scope of the system. So we can say that system boundary defines the extent or the scope of the system, or the extent to which the system goes in order to provide solutions to the problem that exists in the environment. Now, depending on the system boundary or definition of the system boundary, we decide on what kind of complexities, algorithmic complexity and the data structure complexity is to be pursued in order to frame the solution for the problem. So the second important aspect that describes the system is the system boundary. Now once the purpose and the system boundary has been defined, now the third important aspect that describes a system is the structure. So once we have a sound knowledge about the set of objectives and the limit of the objectives, then we can frame a suitable structure, or we can adhere to a suitable structure in order to mold all the complexities into a system or into a package. So a structure is a definitive way of organizing the complexities that would be pursued in order to provide solution to the problem that exists in the environment. So structure is the third important aspect. Now once the purpose, the boundary and the structure has been decided upon, then we need to move on with the description of the function. So the fourth important aspect that describes a system is the set of functionalities that the system supports that a user can use in order to perform a value added work using a system. So the fourth important aspect that needs to be focused on, or that describes a system, is the set of well-defined functionalities. So using these functionalities, the users will be able to perform certain purpose-specific tasks. So every system, in fact, has to be represented in terms of the functionalities that it supports. So these are the four fundamental aspects that describes a system. So a system has to have a well-defined purpose, a system has to have a set of well-defined system boundaries. A system has to have a definitive, well-defined structure that will mold all the identified complexities, and eventually system has to have a representation of itself with the help of well-defined functions. So this is the way how a system is to be interpreted. So now what we have done is we have drawn definition for operating, we have drawn definition for system. Now upon these fundamental basis of operating and system, let us draw an understanding of the term operating system. So we can say that operating system in simplicity is a mechanism of managing all the associated tasks in running a business process with the help of a sound and an able system. So again, I'll repeat it. So operating system is a mechanism of performing all the identified activities associated with the business process with the help of a sound and an able system. So this is what operating system is all about. So operating system enables you to execute business processes, or enables you to perform tasks that are related to business processes with the help of a sound and an able system. So sound and able system basically refers to a system that is very coherent and it's cohesive and it's capable of performing all the activities in itself. So this is what operating system is all about. So in the subsequent slides, what we'll learn about is we'll learn about operating system in greater detail. Now, moving forward, let us try to understand what is a computer system. Now, computer system, as the name says, it consists of four identifiable components. These components are hardware, operating system, application programs, and user. So we have, in fact, if we really map these components, so we have hardware, we have software, and we have user. So now here the software is being categorized into operating system and application program based on the nature of operations it performs. Now let us start with a very brief description of these components. Now hardware. Now hardware in simple terms is a physically existing article of commerce. So physically existing article of commerce basically means any physical thing using which you do business is called as hardware. So this is the actual definition of hardware. So hardware is a physically existing article of commerce. So anything physical with which you do business. Now likewise software is a logically existing article of commerce. That basically means something with which you do not have sensation of touch, but using which you do business is called as software. So here software has been categorized into two categories. One is the operating system, the other one is the application program. So hardware is the physically existing article of commerce. Likewise, software is a logically existing article of commerce. And then you have users. So any external entity, please listen to me carefully, any external entity that uses a system is called as a user. So a user may be a physical user, or a user may be a logical user. Right? So we will try to distinguish between a logical user and physical user when we will be discussing user in detail. So now let us start with hardware. Now hardware, as I said, is a physically existing article of commerce. So computer system has several different types of hardwares. So for an example, you have I/O devices, you have central processing unit, you have memory, and you have system buses. So these are the different categories of hardwares that we have associated with the computer system. So for an example, in case of I/O devices, you have monitors, you have printers, you have scanners, you have joystick, you have various sensors. So these are all I/O devices. These are type of I/O hardware. Now CPU, inside the central processing unit, you have the control unit, you have the arithmetic logical unit, you have the registers. So these are all physical components in the CPU. You have the processor, you have the motherboard. So all of these are hardware that is there in the central processing unit. Now likewise memory. So you have registers, you have cache, you have main memory, you have secondary memory, you have flash drive. So there are various types of memory. So all of these are examples of hardware. Now likewise buses. So you have control bus, you have address bus, you have data bus. So these are typical examples of buses. So these are also hardware. So a computer system has in it a host of hardware that can be categorized into either I/O devices or the components central processing unit, or components of memory, or components of, as I said, the system buses. Now these are all hardwares. Now let us move on to operating system. Now as defined in the previous slide, operating system is basically a mechanism or a program that enables you to perform all the set of activities associated with the business process using a sound and enabled system. So operating system makes uses of the computer hardware in order to realize certain behavior. Now on behalf of whom the operating system realizes behavior is operating system realizes behavior on behalf of the user. Now here it is also to be understood that user may not be capable of directly interacting with the hardware, because user may not be acquainted with the complexities that are involved in using computer hardware system. So for an example, a user may not be acquainted to how the data is stored in RAM, or data is stored in hard drive, or data is stored in flash drive. But using operating system, user is capable of performing operation of storing data into these type of memory devices. So here we can understand that operating system, in addition to performing activities related to business processes, it is also capable of abstracting. Please listen to me carefully. It's also capable of abstracting the underlying hardware complexities that are there in the computer system. So, operating system performs abstraction of the hardware complexities, or it abstracts the layer of the way how the hardware is being managed from the user. So user just have to send in a request to operating system. The operating system on behalf of the user performs operation using the hardware and then returns the result back to the user. So user need not worry about the way how the data or the program is being managed by the or is being performed, or operation is being performed using the hardware. So the entire complexity is abstracted by the operating system. So this is the most important role that operating system performs. So it abstracts the underlying hardware complexity that is involved in performing or storing operations, okay, from the user. Now application programs. So now in a computer system there might be different types of programs that may be installed. So for your knowledge, so there can be either system initiated programs, or they can be either user initiated program. So these application program may be user initiated or system initiated program, runs over the computer system. So it makes use of the operating system in order to interact with the hardware and perform operation. So application program interacts with the operating system in order to use hardware in order to perform operations. Now let us move on to user. Now, as I've said, user basically refers to any external entity that makes use of a system. So here user can be a logical user or user can be a physical user. For an example, we as an end user, we are physical users of a computer system. So whenever I sit and perform operation using my desktop, what I'm a physical user. Now, let us consider another scenario. So, whenever you are buying a product using an online mart, so for an example, if you're buying an item, so for example, you're buying a phone using Amazon. So, what do? So, Amazon is also a system. So, whenever you buy a phone using Amazon, in order to make payments, you use application program that belongs to another system, that is a bank. So you make use of the bank in order to make payment. So now you are performing business using Amazon, where Amazon allows you to make purchase using the link that it has to the bank from where you want to make the payment. So any external system that makes use of the system is also a user. So for Amazon, banking system is an external user, and for a bank, Amazon is an external user. So this is to be understood. So a user can be a physical user or a user can be a logical user. So depending on the context in which the system is being used or is being used by, you decide on who will be the user and who is the system. So a user can be a physical user, a user can be a logical user. So this is the way how user is actually interpreted in case of a computer system. So anything external to a system that makes use of it, may it be logical or physical, is called as a user. So now, what is the role of a computer system? So the role of a computer system is to create an environment that is capable of allowing all of these four components to interact with each other to realize certain business. So this is very much important. So this is the role of the computer system. So the role of the computer system is to allow these four components, identifiably the hardware, the operating system, the application program, and the user, to interact with each other in order to realize certain business. So this is what computer system is all about. So computer system is a mechanism for providing a sound and a suitable environment wherein the hardware, the operating system, the application program, and the users can interact and realize certain business processes. Now, let us have an ordering or a hierarchical or a representation, or very schematic representation of the way how the flow happens. So we have computer hardware. So now operating system makes use of the computer hardware. Then we have application and system program that interacts with the operating system in order to make use of the hardware. And then eventually we have the users. So users, through the application and the system program, interacts with the operating system, which further interacts with the hardware in order to realize certain business. For an example, whenever you're executing a C program, so for an example, if you're using a Boolean compiler, right, in order to write a C program, so you have an application software or application program that allows you to write a C program, okay? It allows you to compile a C program, and then it allows you to create an executable file, and that executable file, with the help of an operating system, makes use of the hardware in order to realize certain business. So that is the way how the computer system is used in order to perform various operations. So the users interact with the application and the system programs, which further interacts with the operating system in order to make use of the hardware in order to realize certain purpose specific business. So this is a very simple but yet it's an important diagram that you need to understand and remember. So here we have learned that a computer system has four important components, and the role of the computer system is to create a suitable or to generate a suitable environment where these components can really flourish and do collaborative work in order to realize certain business. And we have also seen that the application program through the operating system makes use of the hardware on behalf of the user in order to realize certain business. Now, it is important for all of us to understand that what is operating system all about? Why it is important for all of us to know the importance of operating system. Where is operating system being used? When is operating system being used? And what are the types of operating systems that are being currently used? So these are the 5 important questions we need to seek answer for. What is an operating system? Why it's important for us to use operating system? Where are operating system used? When is operating system supposed to be used? And what are the various types of operating systems that are there predominantly used in different types of environment? Now moving ahead, let us discuss what is an operating system. So now here we have 2 pairs of interaction. The 2 pairs of interaction are, one is the user, the other one is the computer system. Now, a user wants to realize certain purpose-specific business using the computer system. Now, the computer system has in it, for example, here I've taken a very simple representation. It has in it a central processing unit, memory, it has in it the I/O devices, it has in it storage devices, it has in it display devices. So as I've said, a computer system has a different categories of hardware. So it has I/O devices in it, it has central processing unit, it has memory, it has system buses that allows the components to interact with each other. So just see, these are the 2 pairs of communication. So you have the user and you have the computer hardware. Now, the user wants to use the computer hardware in order to realize certain business. Now comes in the operating system. So operating system is a program that acts as an interface between the user and the hardware and allows the user in order to realize business using the hardware without having or without knowing or without understanding the way how the process and the data is being maintained by the computer hardware. So, as I've already said, one of the important responsibilities of operating system is to abstract the underlying hardware complexities that are involved in processing and managing data. So here we have 2 pairs of communication, that is the user and the computer hardware, and the interaction is taking place through a program that is called as an operating system. So operating system acts as an interface between the user and the computer hardware. So interface basically means an interaction medium. So now instead of the user sending request to the computer hardware, user sends a request to the operating system. The operating system further uses the hardware, realizes the business and responds the result or response, the outcome of the process to the end user. So just see what operating system does. So operating system receives requests from the user. It uses the computer hardware in order to realize the business corresponding to whatever request has been received from the user, and then it responds sends the response back to the user after performing the necessary operation using the computer hardware. So operating system here is also capable of creating a cordial relationship between a user and the computer hardware. So this is the reason we require operation system. So to enable user to make use of computer hardware without knowing the underlying complexities that are involved in the computational hardware or computer hardware. So that is the role that operating system performs. Now let us highlight some of the important activities that operating system performs. So as I've said, so operating system is a program that acts as an intermediary or as an interface between a user of the computer and the computer hardware. So this is to be understood. Now let us try to highlight some of the important activities that operating system performs. So first one is process management. So process management is a very key activity that operating system performs. So right from creation of the process to preparing process to initiating to allocating memory and its management, scheduling, controlling, coordinating, handling exceptions, and eventually terminating. So operating system handles all the activities that are related to process. So we'll come to that in the subsequent classes. Now the second important aspect that operating system handles are the files. So the way how the files and records are maintained, it's truly classical in case of operating system. So it has, every operating system has a well-defined mechanism of organizing the various files and records that needs to be managed on behalf of the user. So we'll come to that as well. So we will discuss some of the ways in which files are being managed by the operating system. The third important aspect is error handling. So error handling is one of the key aspects of operating system. That is the way how operating system is capable of handling exceptions, and it's capable of maintaining smooth conduct or operation of the processes. So every operating system has to have a very robust and a sound error handling mechanism, because depending on the error handling mechanism or the design of the error handling mechanism for the operating system, we determine the reliability of the operating system. So if error handling is one of the key aspects of operating system. And then we have coordination. So coordination of various devices that are there in the computer hardware or in the computer system. So coordination between I/O devices and the central processing unit, coordination between the central processing unit and the memory, coordination between memory and the I/O devices, coordination between the system buses and the various other associated units. So coordination, that is coordination and control. So I should rather say coordination and control are the two important aspects of operating system. Now next one is security. So security basically refers to a mechanism of allowing only authenticated user to enter into the system and perform operations using the system. So security is also one of the key aspects that we use as a measure for determining reliability of the system. So every computer system has to have a very secure operating system that allows only the authenticated user to make use of the computer hardware in order to perform operations. Now the next important aspect is I/O device management. So every operating system should be capable of efficiently managing the I/O devices that are attached to it. It is also to be understood that with every I/O devices, there are device controllers or device managers. So the device controllers or the device managers should be able to interact with the operating system in order to enable user to make use of the IO devices through the operating system. So for an example, if I want to use any standard printer, so before that we need to install the drivers that are associated with the printers that allows the operating system to access the printers on behalf of the user in order to perform operations. So this is one key aspect of operating system, that is managing IO devices. Now the next important aspect is secondary storage. So every operating system should be capable of efficiently communicating with the various storage devices that may be associated with it. May it be main memory, may it be secondary storage. Now the next aspect is the main memory management. So every operating system should have a very efficient algorithm to manage the main memory, because just see, the central processing unit performs operations using programs and data that is stored only in the main memory. So operating system should be capable of efficiently utilizing the main memory, or optimally utilizing main memory in order to enhance the throughput of the overall operating system. So this is one of the most important measure in determining or in rating the operating system's efficiency, that is how or what kind of algorithm it uses in order to manage main memory. Now the next important aspect is job accounting. So every operating system should be capable of maintaining a very sound and well-defined log of operations that it performs. May the operations be periodic or aperiodic operation, but every operating system should be capable of creating a log of events that it has executed. Now, why do we need this? Is we need log of events that are being executed in order to, first thing is to create a reference. Second thing is to know what kind of operations are being executed by operating system, and to determine what is the ability of the operating system. So job accounting is one of the key aspects that every operating system should look should look into. Now the next important aspect is the ability to network. The ability to network with other systems that are there in the computational environment and collectively realize business using the network system. So depending on the nature and the type of the operating system may be built to work on a single system, or it may be built to work on different set of or a host of systems that are connected to each other. So every operating system is to the minimal expected to network with the other systems that are there in the computer network and collectively realize business as and when required. And eventually the user. So every operating system should be capable of efficiently managing all possible end users that may be wanting to make use of the system. As I've already said, user may be a physical user or a user may be a logical user. So we have also come across example of physical user and logical user. So these are some identified 12 important aspects that every operating system should address to or pay importance to. So operating system acts as an interface between the peers of communication. Here the peers of communication are user and the computer hardware. So the second thing operating system performs is it abstracts all the underlying hardware complexities from the user and makes user pursue or perceive hardware as a black box that is capable of performing operation as and when required. We have also come to know that operating system should address to some of the important aspects like process management, file management, error handling, coordination, security, IO device management, memory management, job accounting, networking, and user management. So in today's class, if we have to go back, we have discussed some important aspects. So let us rewind it. So we have learned what is operating system. We have learned what is operating. We have learned what is system. We have learned what is the significance of operating system. Then we moved on to what is computer system. We came across the components of computer system. We came to know that the objective of computer system is to create an environment where the components can flourish and collaboratively realize certain business. Then we came across a schematic representation of hardware, operating system, application and system program and the user, where application program through the operating system makes use of the hardwares, computer hardwares, in order to realize business on behalf of the user. So that is what we have learned. And then we moved on to the important questions that needs to be answered, which are what, why, where, when, and different types of operating systems. So what is an operating system? Why do we need to use an operating system? Where is operating system used? When it's supposed to be used? And what are the different types of predominantly used operating systems? And then we moved on to the significance of operating systems in terms of communication between the two peers, that are user and hardware. So we came across how the interaction is established between user and hardware through the operating system, and we also came across the different aspects, the 12 important aspects that every operating system should focus on in order to efficiently and effectively realize business on behalf of the user. So in the next class, we will seek answer to the 5 important questions that we have highlighted in the previous class. Thank you very much. Have a very nice day.